In this video, we're really looking at using a z-score in a real-world problem. So here, we're really just going to tie together what we did in the previous two videos into one problem. So number one says, a study finds that the weights of infants at birth are normally distributed with a mean of 3,270 grams and a standard deviation of 600 grams. An infant is randomly chosen. What is the probability that the infant weighs 4,170 grams or less? Okay, so here to find that probability, we want to use a standard normal table. But in order to use a standard normal table, I have to have a z-score. And so my first step here is to figure out what my z-score is. And so I know that formula is that z is equal to my x value minus my mean divided by my standard deviation. Well, I need to figure out what my x is, my mu is, and my sigma. So reading the problem, I see that it tells me that it has a mean of 3,270, so that is my mu. And it tells me that the standard deviation is 600 grams, so that is my sigma. And then it's asking for the probability that the infant weighs 4,170 grams or less, so that 4,170 is my x. So plugging those in, I have 4,170 minus 3,270 over 600. And when you calculate that out, you get that z is equal to 1.5. Okay, now I can go ahead and use that z-score to find my probability. So here, it's important to see what inequality I have. It says that I want to find the probability the infant weighs this amount or less. So that means I want to find the probability that z is less than or equal to 1.5. And so going down to my standard normal table, I have 1.5. So I'm starting at 1, and I want to go to 0.5, and that cross is at 0.9332. And so that means that this probability is equal to 0.9332. Look at another one. So this one says a busy time to visit a bank is during its Friday evening rush hours. For these hours, the waiting times of the drive-through window are normally distributed with a mean of 8 minutes and a standard deviation of 2 minutes. You have no more than 11 minutes to do your baking and still make it to your meeting on time. What is the probability that you will be late for the meeting? Okay, so first I need to figure out what my x is, my mu is, and my sigma. And so reading through the problem, I see that it says my mean is 8 minutes. So that's my mu. It tells me my standard deviation is 2 minutes. So that's my sigma. And I'm looking at an x value of 11 minutes. So that is my x. So find my z-score. I want to do x minus mu divided by sigma. So I have 11 minus 8 divided by 2. 11 minus 8, I get 3. 3 divided by 2, I get 1.5 again. Okay, but now we need to look through the problem to see what type of inequality I have. I know I'm going to have a z, and I know I have 1.5, but I need to figure out whether it's less than or equal to or greater than or equal to. And it says in this last sentence that I have no more than 11 minutes to do my banking and still make it to the meeting on time. But I want to find the probability that I'm going to be late for the meeting. So I want to find the probability that it's going to take me more than 11 minutes to do my banking. So that means this is going to be greater than or equal to 1.5. But remember, for greater than or equal to, in order to use my standard normal table, it has to be less than or equal to. But since the area under the normal curve is 1, I can go ahead and say that this is equal to 1 minus the probability that z is less than or equal to 1.5. Well, we already know that probability is 0.9332 since we had 1.5 in the previous problem. And so when I do 1 minus 0.9332, I get that this probability is 0.0668.